Alright guys, so in this video, I'm going to show you guys how to divide polynomials, because so far you know how to add, you know how to subtract, and you know how to multiply them. Now I'm going to show you guys how to divide polynomial functions. Alright, so the first thing that I want to do is I want to kind of go old school a minute. I want to say, since we're talking about division today, and I'll actually put this up over here, is if I want to do 15 divided by 2, and I wanted to use long division. Well, first I kind of want to go over some terminology. Is if you hear me say dividend, I'm talking about this. If I'm talking about divisor, I'm talking about this value. And then the quotient is basically your answer. I don't know if that showed up, but the quotient is your answer. So if I was doing this out, you would do 15 and you would divide by 2, right? Old school long division. And I would say, well, what you would do is you would take the divisor and you'd see how many times the divisor would go into the dividend. And you would say how many times it goes into it evenly, right? So I know it goes into it 7 times evenly. Now we would take the quotient, right? That's the quotient. And maybe I should list this for you too. So dividend. So those are the parts of a long division or a division type problem. Now we're going to multiply these two together and you get 14, and then you subtract them and you get 1. This right here is your remainder. All right, so that's what's left over. So a couple of things, like back in the day, what you would have, you would write, I don't know, maybe in 4th grade or something like that, you would write 7 remainder. No, excuse me, not 7 remainder. We're doing, doing 7 remainder. Sorry, I got a little screwed up there. 7, right? The quotient 7 and remainder 1. So you might see it like that. Or you might say, I've never seen that before, but I know us teachers, when we were taught long division, we did it that way, or at least I know I did. Then the next part would be, well, you could write it that way, or you could take it and do 7. The remainder would go over the quotient, right? So the remainder over, not the quotient, the remainder over the divisor. So 1 over 2. So the remainder over the divisor. So now we know how to write that. We would do 7. We would take the remainder, put it over the divisor, and we would get 7 1/2. That makes sense, right? Half of 15 is 7 1/2. So when we go to do our synthetic, or when we go to do our long division, not long division because we're not doing long division, what we're doing is a thing called synthetic division. I will pretty much pull up an example for you so you can see long division using polynomial functions. However, it's a little bit of a challenge. I know most of you guys could do it, but we thought as teachers, let's just skip right to synthetic division. Synthetic division is the way to go. All right, so in this example, we have a polynomial function, right? We're going to use synthetic division to divide. So we're going to do negative 3x plus 4x squared plus 9, and we're going to divide by x minus 3. Now, we can only use synthetic division when it's in the form x minus k, all right? So if you notice, that basically needs to be just like this, a binomial. It just looks like this, so that's the general form. So that's the first thing we're going to look at. Yeah, it's like that, so I can use synthetic division. All right, so what I'll do is we'll draw kind of like a half box. And what we'll need to do is take all the coefficients from up above here. So if you look at this, we would go negative 1, 4. However, there is no x value that's within this. So if you think about it, if I wrote this over here, we want to make sure that when we do this, it goes from greatest to least degree. So 3, 2, 1, and then this would really be 0. So what we need to do is use a placeholder. So super important. Pause this, write this down. Placeholder, 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 right? So what we would do is we would write that 0 in right here, and then the 9 would go here. So that placeholder is super important. And at the end, I'll put a steps with some writing in it so it makes sense to you. All right, now from there, the k value, which is really 3, it's not negative 3, so you can always think if it's minus 3 here, you're just going to put the positive 3 here. All right, that's super important, because if you screw up there, the whole thing's going to be screwed up. All right, so the next step, what we're going to do is we're going to bring down the first value, so negative 1, right? Pretty straightforward. Now what we're going to do is we're going to do 3 times negative 1. Well, what's 3 times negative 1? negative 3. Now what we're going to do is we're going to put these two together, and we get 1. And then what we're going to do here is 3 times 1, which is 3. What we're going to do is put those together, and you get 3. Then 3 times 9, you get 3, and then you get 18. So we have negative 1, 1, 3, and 18. Now, you guys probably don't appreciate this as much because you didn't have to use the long division, so just trust me that this is a lot easier once you figure out the rhythm of it and figure out what's going on. So rewind this and see what I did and how I got these numbers. All right, so what these are your coefficients of the quotient, right? This is your quotient right here. So really how this works is this is your remainder, this is your constant, this is your x, and this is your x squared. So what we need to do now is just basically rewrite that. So negative 1x squared plus 1x plus 3 plus the remainder. However, what do we do with the remainder? What did we do over there? Remember, we took the remainder and we put it over the divisor. So the remainder here is 18. What's the divisor here? Well, it would be this guy right here, right? So all we have to do is rewrite that. So that might be a little bit confusing to you, but just think in terms of what we did with the old school way of using long division. So we're just taking the remainder and putting it over the divisor. So we know this is the divisor because we're dividing by x minus 3. All right, and that would be your final answer. And I'll put some steps up here. So these are the steps, step by step by step. You don't have to write those down, but I would pick some key ideas out of that and put them into your notes. So when you do look at your notes, they're a reference. You want to make sure that you guys can use your notebook to look back to and go, okay, I know how to do this. Or if someone picked up your notebook, they would know how to do this. So that's a good way to think about it. All right, here's another example for you. Example 3, we're going to do 3x cubed minus 2x squared plus 2x minus 5, and we're going to divide by, so really what we're doing is dividing. If you can see down below here, it says we're going to divide by x plus 1. Has to be in this form, so the divisor has to be looking something like that, which it is. So we're going to set up our half box. Remember, the k value here is really negative 1, right? Because if I substitute that negative 1 back into here, you would get this. So this would be negative 1. Now we need to set up the inside of it. It's going to be the coefficients, but let's first see if we need a placeholder, because remember I said that was super important on the first example? However, we don't have to worry about it because it goes 3, 2, 1, and then 0. So we're all set. So we're going to go 3 minus 2, 2 minus 5. Now, what was the first step? That's right, bring down this guy. What was the second step? That's right, multiply negative 1 times 3, which is negative 3. And then from here, we're going to combine those. You get negative 5. Negative 1 times negative 5 is 5. What are we going to do? Combine those. Good. Negative 1 times 7 is negative 7. And then negative 5 plus negative 7 is negative 12. So we do have a remainder. So remember, this is your remainder, constant x squared. Now, it might not always work out that way, but for these examples that I'm using, it does. All right, so now we just have to rewrite it as a polynomial function. And the remainder always goes over the divisor. So what was the divisor? This guy right here. So we do x plus 1. And that's it. Okay, so the steps stay consistent every single time. The big thing is the placeholder there, and make sure you understand that placeholder. And that's about it. So let's do a few more examples and we'll get you out of here. So for this next example, what I'm going to show you guys is the remainder theorem. And we can use synthetic division to solve or to evaluate polynomials. So if I had you guys take a few minutes to solve, if I said, what is this expression when x is equal to negative 4? You guys would do this. And from here, what you guys would do is you'd substitute this into a calculator. So go do that right now. Pause and see what you get when you do this. I already did it on a calculator, but just check to see what you would get. All right, so now you guys can see when we evaluate for negative 4, we get negative 359. So I'm going to show you how to use synthetic division. So we're going to set up the same way that we normally would. However, it's saying x is equal to negative 4, so that's really my k value, right? That's my k value, so that's just going to be negative 4 on the outside. Coefficients, we want to make sure, do we need a placeholder? No, we don't. So we're going to go ahead and just write it out. 5, -1, 13, and 29. Now we're going to run through this, and what the remainder theorem states is if this value, the remainder, if we get something there, that's the solution, right? So we know whatever we get in this location, we know it should be -359, but we'll check it out and see if it works. We'll see if it makes sense. So bring down the 5, -4 times 5 is -20, 21, -4 times 21 would be negative, what would that be, 84, right? And then from there we want to subtract that. Actually, that would be positive. Oh, I see what I did. -1 times -20 is -1 plus -20 is -21. We're adding those, so I screwed up there. That's why this would be positive, because -4 times -21 is 84. And then from there you get 97. And then if you try to do this in your head, it might be a little bit difficult. So off to the side, we could basically do this out. We would get 28, 36, and then add 2 to it, so 388. 388, however, it's going to be negative, right? Because we're multiplying that and that, so I really should add negative there, so that'd make that negative. And then from here, all we're doing is subtracting those. And if you can't do that one in your head, let's do it off to the side just to confirm. So 7, 9, 5, and which one was bigger? The negative was, so this would be -359. Is it the same as what we had over there? Yes, it is. So we can use synthetic division to evaluate. Sometimes it's a lot quicker, a lot faster, especially if we don't have a calculator, right? If I was trying to do this out in my head, that's going to be tough. I'm definitely going to screw that up. And I know some people in here probably could do it in the head. I couldn't, but I could do this on paper without using a calculator. So that's how you use synthetic division to basically evaluate a polynomial function. All right, guys, so that's the video. If you have any questions, please reach out to one of us so we can help you out. As you know, we're not alone in this. And actually, I want to give a shout out to DJ Walsh. He found a mistake in my previous video. So if that ever happens, that's helpful for other people that watch the video. So sometimes I edit these real quick and I don't catch it till after the fact. So if you guys do see that, kudos to you. So thank you, DJ, for pointing that out. But keep up the good work, guys. You guys have been killing it. So let's keep going. And I'll see most of you guys in the hallways. And I'll see you guys in the classroom. All right, adios.